Good afternoon, students. Today we will be starting the gel chromatography for the unit 5 of the semester 7. That is chromatography, you know very well. That is a separation of different molecules according to their affinity and according to the principle of absorption and adsorption. So in case of gel chromatography, where gel will be used as a stationary phase and different molecular size and especially higher molecular weight containing compound will be separated. Now going to the principle here. So in case of gel chromatography, also known as a gel permeation or molecular sieving size exclusion chromatography. So this gel permeation chromatography or gel chromatography is also known as the size exclusion chromatography. In case you find anywhere size exclusion chromatography, that you will be understanding that it is saying about the gel chromatography. That is a chromatographic technique in which the separation of component is based on the difference of molecular weight and size. And one of the effective method used to isolate and analyze the bio-macromolecular substance. Macromolecular substance means the highest molecular size containing compound and the largest weight contained. The stationary phase consists of beads containing pores that span a relatively narrow size range. That means the stationary phase will be consisting of the beads containing pores. The beads will containing some spores relatively and span a relatively narrow size range. That means they will be absorbing some narrow size compounds. When the gel is packed into a column, one second. In case of gel chromatography, when the gel is packed into a column and percolated with a solvent, it permits the larger molecular weight component to pass faster with the penetration of the pores that is totally excluded. That means the gel will be packed into the columns and some of the solvent will be percolated in that stationary phase. It permits the large molecular weight component to pass faster. That means large molecular weight component will be passing faster without penetration of the pore. That means the larger molecular size cannot be absorbed into the pores of the gel. So totally excluded. So larger molecular size will be excluded and the smaller molecular size component will be fixed into the gel. So smaller molecules spend more time inside the beads that are permeated and therefore is eluted later. After a larger volume, the mobile phase has passed through the column. So that means we require larger molecules to pass faster and the smaller molecule will be passing slower and the molecules will be passing with a maximum number with a larger volume of solvent. Here you see the diagram. See, this is stationary phase here. The beads are here. The larger molecules, the yellow color beads are larger molecule which will not be absorbed and that will be eluted, and the smaller molecular size component that will be fixed into the pores of the beads. And some of the, if it is a component of three mixer like yellow and the ash color component, red color, where the pores will be fitting the small molecules, and some of the, if the beads having a specific capacity to hold that amount of molecule, then it will fitting, otherwise it will be eluting in a small extent or a later on. That's the higher molecular size, that is a yellow colored compound will be fasting eluted fast, then the red color and then the ash color compound. Okay, now here we see the permeated analyte that can fixed, it is analyted, and excluded analytes that will not be fixed into the gel, and it is excluded, and the analyte which will be diluted later on and that have to be analyzed. So in case of gel filtration chromatography, principle of the method, a resin based schematic represented as a wiffle ball, yellow colored, that is resin, one of the resin. Large molecules blue, that is beads, that is blue colored molecules cannot fit into the beads, so they are confined to the relatively small buffer volume outside the beads, so they will be eluted with the buffer. Thus they emerge quickly from the column, and small molecules by contrast can fit into the beads and so have a larger buffer volume. Next, this is the principle of separation. That is very easy principle. Now there are different pictures. Sample is applied. See, this is a column where the stationary phase having the bits of the gel. Now, molecules having different size, biomolecule, macromolecules will be uh, filled in that column. Sample is washed through some buffer. In the interstitial phase, the larger molecule will be eluted and small molecules will be fixed into the gels, pores of the beads. And after washing with different solvents and buffer, the smaller molecules will be corrected. This is the schematic diagram. So, if we report in the peaks, then we can see so sample injection volume. It will be coming into a equilibrium phase. Then high molecular weight component will be eluted, and you can get a highest peak. Some intermediate peak you can get that you can say that intermediate molecular weight will be there, okay, and low molecular weight component will be eluted later on. Okay, so void volume V0, that is at that phase no molecule will be eluted. Total volume count, which is a VT, that is the how much volume has been eluted. So theoretical chromatograph of high resolution fractionation, that UV absorbance detector or biomacromolecule volume, the protein or other type of substance. Now properties and nature of the gel. The gel should be chemically inert, that means it should not react with other component. Be mechanically stable and has ideal and homogeneous porous structure. White pore size results in low resolution. Ideal and homogeneous porous structure. That all the beads should have homogeneous porous. Wide pore size results in low resolution. If the pore size are larger, then resolution will be low. That means smallest size molecule will not be fixed. Suppose you are taking a filtration or filter paper. If the filter paper having larger pore size, then the impurities and other unwanted particles will be coming out. Small particles which should be retained in the filter paper, that will not be retained. Okay, so there will be mixture of components that is not required. So the bits size will having same homogeneous nature. As a result, it will get good resolution. Uniform particle and pore size. The pore size of the gel must be carefully controlled via the degree of cross-linking. The pore gel must be carefully controlled. That means we should choose particular gel which have the good pore size. Now coming to the types of gel, what are the types of gel are used? One dextran, that is Cephadix gel, and agarose gel. So what is the name of the component? Alpha 1,6 polymer of glucose, that is prepared by the fermentation of the sucrose, that is a component of glucose and fructose, that is a natural gel. So whenever it is fermented, it will produce a polymer of the glucose, that is known as a dextran, that is known as the Cephadix. And agarose, that is obtained from the agar and composed of alternating units of 1,3-link beta-D galactose and 1,4-link 3,6 anhydro alpha L galactose. It's a natural gel. So this type of two gels are used. One acrylamide gels, that is also very important, polyacrylamide gels. It is not dextran polymer, it's a polymerized acrylamide or methylene biacrylamide. That's a synthetic gel. Okay. In case of PEG, that is used for the gel electrophoresis, we have also used this PEG in case of protein separation. According to the swelling process, the gels are of two types. One is soft gels, that is zero gel, that is only used, is gel only on the swelling, it is working. That is polyacrylamide gels, dextran or agarose, used for the separation of proteins in aqueous mobile phase. And semi-rigid or rigid gel, that is the aerogel, it is a gel in air. Polystyrene gels, it is separation of non-polar polymers in non-polar solvents. Porous glass gels, separation of the polar system. Now coming to the eluent. The eluent will be the mobile phase, should be a good solvent for the polymer, should permit high detector response from the polymer and wet the packing surface. It may also buffer. That means the eluent should be having a good particular detector response. Next advantage of gel filtration can handle biomolecules that are sensitive to changes in pH, concentration of metal ion or harsh environmental condition, presence of concentrated acid and base. If some of the material is containing some metals or some harsh metal that can be separated. Separation can be performed in the presence of essential ions detergent at high or low ionic strength at 37 degree or on cold according to the experimental requirements. Common terms in size distribution chromatography. The total volume Vt, the sum of the volume of the gel matrix, the volume inside the gel matrix, and the volume outside the gel. The total volume is also equal to the amount of the eluent required to elute a substance through the column, which is small enough to completely penetrate the pores of the gel. That means total gel matrix, the volume inside the gel matrix and the volume outside the gel matrix, total is known as the total volume. That means how much will be eluted and how much it is retained in the column. It is totally known as the total volume. Inner volume, it is a VI. The volume of the eluent inside the gel matrix, the volume inside the bits, that is remaining in the gel. That is known as the inner volume. Next, void volume. The volume of the eluent outside the gel matrix, that is, this is the volume required to elute a large substance so that it cannot penetrate the pores at all. Such a substance is said to be completely excluded, such as dextran blue 2000. So that is when the void volume will be there. That means some of the larger molecule will be eluted, and that is known as the void volume. That means in that void volume, no small molecules or the analyte will be coming out. Elution volume. The volume of the eluent required to elute in any given substance. Now gel volume, the volume of the dry gel. If we draw this picture, we will get the V0, then VE, the eluted volume, and VT, total volume. Okay. So here you can see the poly diagram here. VT, total volume, and V0, that is the void volume. You can see like this by this column. You can graphically get this diagram, graphically get this definition. Just wait. So you can get this definition in your examination. What is void volume? What is the elution volume? What is gel volume? And what is total volume? Now Vt is actually V0 plus Vi plus Vg. That is the gel volume, initial volume, and void volume. In classical and more rigorous sense, elution position of any molecule should be reported as the partition coefficient KFE, KAV. That is the V minus V0, eluted volume minus void volume, and Vt minus V0. That is the ratio of that two component. That is known as the KAB, that is the partition coefficient. By this way, you can get the partition coefficient of that component also for totally exclude. Now separation procedure, the preparation of the first how it will be working. Preparation of the column for gel filtration, that's first swelling of the gel, then packing of the column, then washing the resin, then loading the sample into the column, then eluting the sample and detection of the compound. These are the general principle which is followed everywhere in the chromatography. Here you can get the graphical representation, elution volume, glutamate, dextronase, and lactate dehydrogenase. These are the different kind in enolase kinase. Here you can get different peaks of different enzyme and cytochrome C, and this type of component can be separated through this process. Fractionation of macromolecules, you can get the macromolecules in fraction, and that is desalting. That is a group separation can be used for from this method. Here the gel filtration chromatography which have been seen before the study of the chapter. So here the larger molecule will be eluted first. So then the second largest component, then the smaller molecule will be eluted. Okay. Here different diagrams can be seen. See, by one you can see it. So this is the method of gel filtration chromatography and application. You can see a fractionation of macromolecules and desalting can be there. These are the different applications. Okay. So application of molecular weight determination. So in case you can get the, so from this chapter you can get the question, what is gel filtration chromatography, what is the principle, what are the different gel you are using, what are the partition coefficient for the gel chromatography, what are the procedure of gel filtration chromatography, and different applications, and what the small definition can be get, can get the void volume, eluted volume, total volume, this type of question you can get. Thank you everyone for listening.